Welcome back, students. Brandon here again, continuing our topic on logic. So if you remember the last video, we talked about those basic building blocks, and I said pay particular attention to the conditional statement, and that's what this video is going to be talking about now. So remember, conditional statements are those that kind of have that if-then kind of relationship. So if something happens, that's going to trigger the latter thing to happen. It's our P implies Q statement. So right up here, I've got, if it rains, then I will use my umbrella. A very, safe statement to say. I don't want to get wet. So if it's going to be raining outside, I better want to use my umbrella. So we are going to manipulate this conditional statement again in different ways and, just kind of see what happens. So the first manipulation that we're going to be looking at is called the converse. And essentially what that is both of our statements put on their converse and they walk to the other side of the conditional statement, of the arrow. So in this case, it is Q implies P. In our context, in our original statement, it says, if I use my umbrella, then it will rain. But that's not necessarily true, right? I could be using my umbrella and playing golf with it. I don't know why I went to that first, but I could be using my umbrella because it's really hot and sunny outside and I need some shade. That's probably a better use of that. So I could be using my umbrella and it not be raining. So a lot of people like to say that if this is the case, then this is an equivalent case in which we're going to call it logically equivalent, but these two are actually not logically equivalent. It's what we call the converse error. So that's something to watch out for. Our next manipulation is called the inverse. And it inverts each of our statements. So it takes P and turns it around. It makes it not P. And it takes Q and it turns around and says it's not Q. In terms of our original statement, what it says is if it does not rain, then I will not use my umbrella. And again, for the same reason as before, it's not equivalent to our original statement, because there are cases where it's not raining, but I still use my umbrella. So again, people like to switch these two all the time, even though they're not equivalent. Another thing to note with the inverse is you might be thinking that the inverse is the not for the conditional statement. And that is not true. And we'll see in a little bit what that might actually be. But more on that later. The final manipulation that we're going to see is the contrapositive. And it is a combination of these two. You invert the statements and you switch their locations. So this is a not Q implies not P. And so this says, if I do not use my umbrella, then it will not rain. If I don't use umbrella, then it's not raining. And finally, we have a case that is actually equivalent. We've already made the statement that if it's raining, that's cool. If it's raining, I'm not going to use, or then I'm going to use my umbrella. If I'm not using my umbrella, then it certainly isn't raining. Because I've already said for myself, raining implies that I've used my umbrella. Those things are logically equivalent. In the same way, the converse and inverse are logically equivalent. You often see these three lines for logically equivalent. But converse and inverse are logically equivalent, and the conditional and the contrapositive are also logically equivalent. If you have a hard time trusting that, let's look at the truth table for the contrapositive. So now we're finally getting to a more complex truth table. So, again, we've got P, we've got Q. Our end result that we want is not Q, implies not P. So, in both of those, we're going to need not P, and we're going to need not Q. And then we can do our not Q implies not P. So, let's make this big. Again, set up your chart like before. Remember, there's two statements, which means there's 2 times 2 rows, or 4, and it always is going to take the form true, true, false, false, true, false, true, false. Not P means switch the truth value for P. So we've got false, false, true, true. Not Q, switch the truth value for Q. False, true, false, true. And then not Q implies not P. Now you have to be very careful. You're going from this column to this column. If the original statement is false, then our overall statement is true. So that's going to take care of row 1 and row 3. True implies false is false. True implies true is true. You might notice that this is the same construction as if P then Q. Since they are the same, they are logically equivalent. And that's what it means. In every single case, the truth value of the corresponding statement is also the same. So true and true and false, false, true, 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 true. Always the same. That's what they mean to be logically equivalent. Now, going back to another question that we looked at a little earlier, if the negation of this is not the inverse, that's not true. What is the negation? And I could spell out the entire truth table right now, but let's just kind of look at it. So the negation switches all of these truth values. So it'll be false, true, false, false. The only statement that is true is the place where P is true and Q is false. So the negation of the conditional statement is in fact P and not Q. That is our negation. So going back to our original statement, if it rains, then I will use my umbrella. The opposite of that in every regard is saying it rained and I did not use my umbrella. The one case where I said I was going to use my umbrella, I did not, in fact, use my umbrella. So that is a bunch about the conditional statement and manipulations of it and the negation of it. And so hopefully you understand a little bit more about the conditional statement. And I'm going to stop the video here, and in the next video we're going to cover a really complex argument and a more complex truth table and see how we can use truth tables to kind of express or test the validity of the argument. So see you then.